that you have an excellent exposure today at the end of this webinar on this topic. One of the things that which wanted to ponder on is that a lot of our applications are migrated to cloud. And we blindly trust all the cloud providers. It could be AWS, Azure, GCP, or public cloud, or any kind of hybrid clouds, private clouds. So a lot of our data is going there as an enterprise data. The question that we wanted to understand is that, is the security given by the cloud provider is enough? Or is it that are we still under concern that whether our data is secured? And especially when you are using multi-cloud solutions, how is this data going to be secured? And in terms of this understanding of where are we going wrong in not securing our data? Is these are minor misconfigurations errors, or is it very large persistent attacks are coming on cloud? And to ask these questions and to understand about the various aspects of cloud insecurity, and also to understand how to mitigate this, let us welcome Nishant. I know that Nishant has a lot of fan following. Nishant has been our favorite mentor in cloud security for all our corporate training programs here. Though he is situated in Bahrain, he has been working with us in various aspects in terms of training, capstone projects, mentoring, etc. And he comes with solid decades and more experience as solution architect. And as a solution architect, he had implemented cloud solutions across industries and sectors. And he's a non-expert in security engineering, privacy engineering, automations, site reliability, chaos engineering, DevSecOps, anything on depth and breadth of it. And I'm sure that some of you have listened to his training, really understand how good a student he is. And though he has a post-graduation and continues to complete his masters, etc., he's always a learner. And that's what we like about Nishant, that he has been part of multiple organizations, including RACE as a mentor, but he is also a subject matter expert for various committees and various organizations in cybersecurity. So cloud is one of the area, but he is also an expert in cybersecurity in all aspects. So today he is going to discuss about what is cloud security, what kind of threats are generally there, and how to mitigate that. And in this 1 hour of webinar, we are hoping that you will get a very good understanding. And especially if you are moving on to this cloud security area, we would want you to note down points, ask questions. There is chat window open. Please ask questions. And towards the end of this webinar, which is about say 45 to 50 minutes, we will curate the questions and come back to ask questions to Nishant. So with that, I'm so delighted, Nishant, to have you on this webinar. We got very, very overwhelming response onto this topic, and thinking, and this is a sign that this topic is very, very important for organizations, for individuals, and for a learner generally. So over to you, Nishant, and looking forward to a great engaging session. Thank you.
Thank you, Dr. Shinu. Good evening, everyone. Good morning and good afternoon. Those who are joining from different time zones, I warmly welcome you to the Cloud Security webinar. So as most of you understand that, today every organization is trying to move to the cloud. So let me, as some of you already know what is a cloud, but let me quickly start with the definition. Cloud is nothing but someone's computer. That's an easy way to understand. Someone's computer is what you are using it, and for whatever the purpose that you are using for, if you are using for 1 hour, 2 hours, 3 hours, you're just paying for what you use. That's a very, very fundamental cloud definition to start with. So whenever we understand about cloud and cloud security, right, we need to definitely understand what are the different models that were available in the cloud. So let's go ahead and first understand the models in cloud and then continue our discussion from there. And if you look at my annotation here, typically we used to have this traditional on-premise IT. This consists of a data center, a couple of network infrastructures like routers, firewalls, switches, proxy devices. You will have your physical servers. On top of these physical servers, to optimize the resource usage, we do virtualization. We use technologies like VMware, Citrix, and QEMU. On top of that, you run your operating system. So on a bare metal server, you can run different kinds of operating system using virtualization. On top of these operating systems, you deploy your applications and databases, typically MySQL, Oracle, MS SQL, or MongoDB, Cassandra, whatever type of database that you want to take, you can install on top of that. And then you have an application, whether you want your web application server, whether you want a web server, whether you want a Java applet kind of an application, you typically install on top of that. And then these applications, you insert data into the application, because once the applications once the user starts using these applications, a lot of data gets generated and the data has to be managed. If you look at all these levels in a traditional IT, everything has been taken care by your team. Your organization takes care of everything. Your IT engineers will take care of almost everything that is mentioned here. In some organizations, they may outsource this job to a consulting company or a third-party company. But they are still considered as internal employees, even though they are outside, but they have just outsourced the job. It's not a third party who is actually giving you the service. That was a typical traditional model we used to have. And then we slowly moved out from that model, a colocation model. Typically, colocation model is used by some companies where they want to have a BCDR infrastructure, where you have a business continuity and disaster recovery infrastructure. They don't want to pay high costs on the real estate, so the data center is leased by the supplier from a third party, and then they put up their own network devices, physical servers. They do their own virtualization. They install their operating systems, databases, application, and data management. So except the data center, everything is managed by us. That's a typical colocation model. And that because here the real estate cost is very high, you are saving a lot of cost on the real estate and real estate maintenance, the infrastructure, physical infrastructure maintenance. Then we slowly moved on from colocation model to the hosting model. In a typical hosting model, data center, physical data center, the components like network devices, routers, switches, cabling, and then storage devices, and the physical servers are typically maintained by the hosting provider. And we log into the direct bare metal server. On top of that bare metal server, we typically put our hypervisors like VMware or Citrix. On top of that, we install on our operating system, databases, application configuration, and data management is typically done by us. So in this case, if you look at, there is a shared responsibility. Physical servers, network storage, and data center are typically maintained by the supplier, and remaining layers are maintained by our own teams. And these three were typically traditional models before the cloud. But since 2006, when this AWS started introducing you cloud features, cloud comes with three models: infrastructure as a service, platform as a service, and software as a service. If I start looking at infrastructure as a service, data center, network storage, physical servers, and the virtualization component is taken care. Once the virtualization component is taken care, let me put an annotation here. You see these boxes. Let's say these are your hardware boxes. Once the virtualization layer is taken care, the provider will provide you the virtualization layer in such a way that you don't care about the underlying infrastructure hardware. You only care about what amount of compute power you need. That will be taken care by the provider. You just need to request that I want maybe 1 terabyte of RAM. The provider will give you the hardware. So on top of this virtualization layer, you install your operating system. On top of the operating system, you put your own database. You install the database, configure the database, manage the database, take a backup of the database, upgrade the database, downgrade the database. Deploy the application, upgrade the application, downgrade the application, fix issues in the application, and then data management. Securing the data is our responsibility. In this case, if you look at infrastructure as service, most of the hardware job, most of the tough job, uplifting job is taken care by the provider, and we are only worried about our own tech stack of application. And then we moved out from infrastructure as a service to platform as a service, where data center management, network, physical, virtualization, operating system, as well as database configuration and database management, upgrading, downgrading is taken care. You are only worried about your own application and the data inside the application. So that means who has access to what data, and which one should, which user, which administrator, which employee should have access to what data is only taken care by you. That's a typical platform as a service. And then we have a software as a service, which most of us use on a daily basis, where except data, everything is taken care. One of the simplest and easiest example to start with is your Google Drive, your OneDrive are the basic and best examples for SaaS, where you upload your photos, you upload your PDF files, you upload your music files. However, you never build, you never maintain anything. So the best example to start with in the reverse order is, the best example for SaaS is a simple Google Drive or OneDrive. And then you have a platform as a service. The best example is Vercel. Today, everyone wants to deploy their application, but none of them want to manage the underlying resources. Okay, Cloudflare is another best example, where you have your application, you just need to take this application and drop this application on the server, and that's it. You have the entire environment up and running. Vercel, Cloudflare, Netlify, which many people use to go ahead and deploy the applications. That's a easiest and the most common example. And then we have infrastructure as a service, typically virtual servers or EC2 instances if you are coming from AWS background, or VMs, or compute if you are coming from GCP background, where the operating system is under your control. And if you look at all the models, there is always some sense of responsibility from colocation till the software as a service. Maybe in colocation, I have to take care of many of the things, but my provider just ends up giving me a hardware and the data center infrastructure, maybe from a physical point of view. But as you end up with SaaS, the responsibility on you will decrease, but the responsibility on the cloud provider will increase. If we are able to understand these colocation models, right, I think we should be good enough to exactly draw the line between who is responsible for what. And if I take an example here, in case of a SaaS, like a Google Drive, you will be never responsible to upgrade the network infrastructure. You are never responsible to upgrade the server. Your team will never be responsible to identify the bugs in the virtualization layer or optimize the virtualization layer. You are never worried about operating system. You are never worried about database management, and you are never worried about application management. You just pay per user and consume the Google Drive service. Pay per GB, pay per user, pay per license, and then you will go ahead and start using the application. And today, today's businesses, today's customers demand a lot. If you're a business and if you're building a B2C product, your customers would demand a lot from you. That they just want innovation every day. And companies who are providing services to multiple customers, they have to innovate. And if they are on a SaaS, maybe the innovation that they can do is a little lesser. But if they are on a PaaS, the amount of innovation that they can do is a little more higher, but they don't need to do the heavy lifting work. But some organizations may have to innovate and do heavy lifting, where they can go for infrastructure as a service. And our predominant concept for today is going to be cloud security. So it's important to understand the roles and responsibilities. We also called as a shared responsibility model, where cloud provider as well as the customer. Both of them will take some sense of responsibility. I hope that is clear. And I know there are some questions that I see on the chat box, but we will try to answer them maybe in the last 10-15 minutes. And then let's make that as a way to discuss. But if you are able to understand infrastructure, platform as a service, and software as a service, I think we should be in a good position to draw the line of who is responsible for what. So now this is a typical cloud models. Now let's look at what kind of threats that can happen on the cloud. So as per one of the reports from Cloud Security Alliance, these are some of the common threats that someone can see. One is an insufficient identity access, credentials and access management, insecure interfaces and APIs. Again, we will be having a little more detailed discussion on this. Misconfiguration and inadequate change control, lack of cloud security architecture and strategy, insecure software development, unsecured third-party resources. We'll understand about each of these threats. System vulnerabilities, accidental data disclosure, misconfiguration of serverless containers or an ATP attack, and the data exfiltration. Let's look at some of these attacks in detail and understand what kind of attacks are typically possible and some of the real world examples. Let me start with insufficient identity credentials, access and key management. Let's look at a scenario and then we will understand the concept in a better way. So if you look at, this is an event that happened in 2021. Okay, around 128 GB of records got exposed from a company called as Twitch. Now, Twitch is a company which will help you to stream your games. If you want to do any kind of a streaming apart from YouTube, you can do it on Twitch. Because of a configuration change that happened, okay, this 128 GB records have been disclosed. Let's look at another example. Again, this happened in 2021. Around 20 GB of data, around 500K individuals, unique data has been exposed from an Amazon S3 bucket. You can think of Amazon S3 bucket as a Google Drive or a OneDrive. And all this happened just because of improper identity access management or improper key management. So again, the examples that we are going to discuss are very specific to each of this scenario, but multiple examples will be there. There's another example here, which is from Capital One, which is again a financial institution, where the roles and responsibilities of the cloud providers are not properly understood, and the misconfiguration of which has approximately 100 million individuals. And we are talking about these case studies not 10 years, 15 years ago when the cloud is not mature. We are talking about these case studies which are 3 years, less than 3 years old case studies. There is an interesting case study from Google where Google has deleted the UniSuper's data, and when I come there to the appropriate thread, we will be discussing that. But these are some examples where in the last couple of years we have seen how insufficient identity credentials, insufficient access controls, insufficient key management have faced the issue. So typically what we do is, if you look at a risk scoring matrix, if you are taking 3 categories, one is the security responsibility, architectural issue, and then the cloud service model. Okay, so let me start with cloud service models. Whether you choose infrastructure as a service, whether you choose platform as a service or software as a service. Identity management, that is creating the users, giving the permissions to the users who should have what access, and maintaining their access keys, is still the responsibility of the customer. It is not the responsibility of the cloud provider. Cloud provider will not take responsibility, nor it is a shared responsibility. It is always the customer's responsibility. That means if you are using even SaaS, PaaS, IaaS, it is always the customer's responsibility. And if you are an engineering a person who is actually trying to build systems on cloud, okay, except infra, because cloud provider will take care of it, your application management, metadata management, and the data and the configuration information regarding your application and systems have to be your responsibility. That's why to mitigate, what we do is we have something called as risk scoring for identity and access management. Like, in a risk management, we typically give the risks for the risks that you have in your organization. Very similarly, when you have a set of users, and when a couple of users are privileged users, some of them are non-privileged, even for the privileged users, you will go ahead and create a risk matrix. Maybe something like high, medium, low, where, okay, my CEO access is very important and it's highly sensitive. So I'll just go ahead and categorize as high. Maybe a senior manager, which is medium, maybe a clerk, which is low. So I can actually give a risk scoring. It can be in the form of high, medium, low, confidential, non-confidential. It can be any type of a scoring, but you have to score the identity and access management. And being a consultant, I have done implementations for multiple organizations, and I realized that it's very rarely people manage IAM very nicely. And you see, with the experience of auditing multiple companies, I can tell that if you have to find issues in any cloud environment, the best place is to go to identity and access management, because there will be a lot of policy deviations that you will see, mainly in cloud IAM. I'm not talking about data center, but in a cloud IAM, because in a cloud IAM, you will have thousands of policies. For each combination, you have easily take any cloud provider, you have minimum 150 services. And these 150 services will have read access, write access, execute access, admin access, and permutations and combinations. And you can think of what possible. And if you have 10 roles, these 10 roles with these 150 services permutation combination will be clumsy. And you look at by default, if you look at AWS, there are 800 plus policies that are given. And I'm sure when one user has 800 policies and then he has to manage all of them across the organization, it will always be a clumsy. This is one area that is that's one of the highest pain point. And due diligence of continuously monitoring which user is accessing from what location, from which IP address he is accessing is very important. And then performing a behavioral analytics, like Nishant is a user who typically accesses from a United States region, but suddenly one day he is accessing from India. That's not his behavior. Typically, he never types his password 3 times. In one go, he logs into the account. But suddenly you start seeing that 3 times he is typing wrongly. That's a behavioral change. Even that kind of a behavioral address, if we can address, we can fix issues with identity and credential management, mainly at a identity and access management level. The other important area is insecure interfaces or APIs. So let me take one case study here. This happened again in 2021, where there was an issue with the APIs, okay, from Experian, has exposed the credit cards. Credit card information of millions of customers has been exposed because of the misconfiguration in the APIs. Now, why we have to talk about APIs? If you look at a cloud environment, right? And if you are a user, you have 3 ways to access the cloud. Either you can use a GUI to access the cloud, you can use the CLI to access the cloud, or you can write a simple program. You can write a small program to access the cloud resources. Let's say I want a server. I can go to the AWS GUI or Google GUI or Azure GUI, and then I can create a server there. Or I can run a couple of commands on my PC with the CLI softwares, and then I can spin up new servers. Or if I have a computer program like a Java, Python, .NET, Node.js, I can just write a simple Node.js program and spin up an EC2 instance or a virtual machine or a load balancer or a firewall on the cloud. Now, whenever you interact in these 3 modes, okay, GUI is pretty normal because the GUI is not hosted with you. GUI is on the cloud provider. But the CLI and the programs, when you run, Okay, they get executed on your client computer and they perform the operations on the cloud. Because they perform operations on the cloud, there should be an interface between your computer and the cloud. Typically, cloud exposes APIs, application programming interface, where you can run couple of commands and they are converted into a JSON object and then they are sent to the API. And if these APIs are not secured properly from the cloud provider, okay, some malicious actor can just go ahead and access these APIs. And we have seen with some providers where they have exposed these APIs in a wrong way, or they could not put protections against these APIs, and data exposure or data leakage has happened. Here we can see two cases, and these two cases happened in the last 3-4 years. And how do you put protection mechanisms? And the weaknesses are here. Unauthenticated endpoints, that means there is no authentication for your APIs, so you don't know who is accessing what API. Or you have authentication, but they are weak, they're using weak algorithms. Maybe you have authentication, you have a strong authentication also, but improper permissions, over privileges are given. And there is one example, this is from a Pegasus airline, which is a Turkish-based airline, where all controls were good, but one engineer has disabled the security. That means by default the security was enabled, but the engineer mistakenly have disabled, and 6.5 terabytes of data has been leaked in 2022. That means almost every customer who could have traveled in Turkish Airlines, the data is out, because that standard controls are given by the cloud provider, but due to improper due to misconfiguration, there is a lot of chance that you will lose the data. Unpatched systems or improper logical designing of APIs, or you are not monitoring it on who is accessing what on a continuous basis and analyzing. These can be some issues where you will have challenges in protecting these APIs. The other important thing is misconfiguration. We all think that every change that we do in our organization will undergo through change management process. There is a strict guidelines, but still big companies are still making mistakes. Let's look at, again, I'm not trying to defame any company over here, but rather I want to take as a case study or an example, and look at ServiceNow has released guidelines on how can you go ahead and avoid high privilege misconfigurations. And if you look at, there is an AWS S3 bucket leakage from a software company, and millions of records got exposed. And this is just like 2020, this case study happened because of misconfigurations. Because many times we have unprotected buckets or unprotected blob folders, unprotected object storage on the cloud, so people don't take care of it. And many times, if I have to take a personal example, many of you use OneDrive, but OneDrive has something called as ransomware protection, where if what OneDrive does is, if you have a copy on OneDrive, it always makes 2 copies of OneDrive, not 1 copy. It's always a 2 copies on the server side, and one is always encrypted with a key. So in case of a ransomware, your primary data gets encrypted. You can still recover from the backup data. You just need to go a couple of options, and you should be able to retrieve, even though your data that is synced to OneDrive on your laptop gets encrypted, you can retrieve the data. That's an option that not everyone enables it. You can go ahead and enable it. If I remember correctly, I think that's only available for family users or someone who has purchased the OneDrive subscription, not the free one with 5 GB, but the one with 1 terabyte or 100 GB subscription that is available. Yep. And all the 3 last were typically from a technology issues, but there is always issues with the lack of cloud security architectures. That means the strategy that the organization has taken may not be good. I'll take one example here, which just happened recently. And if you look at, this happened in 2024. And if you look at this, Google has accidentally deleted UniSuper's private cloud subscription. So there was a subscription from this company called as Unisuper for Google, and Google has accidentally deleted all the data. When I say all the data, literally the backups are also deleted from the Google Cloud. And is it a is it an automation error? No, it's a human error. A human was trying to upgrade, something happened, and then all the data got deleted. Now, what was happened? It was not detailedly articulated, but there's some kind of a goof up happened. There may be some case studies that were out, but just to understand this here, that if you go ahead and rely on single cloud, okay, and if that cloud provider, by any reason, due to any reason, unforeseen reasons, if that data is deleted, we are out of market. And I have to really appreciate the engineer who has done the strategy for Unisuper. Thing is, their primary cloud is GCP, their secondary cloud is Azure. That means they have one set of infrastructure at a highly scalable running on GCP, Google Cloud, and then all their backups are sitting in GCP, as well as they have a secondary infrastructure running on Azure as well as data center. So they have a hybrid model where two cloud providers and data center. And because even though the entire data on the GCP is deleted, the primary servers, less than a week, they have come up and they started doing their business without losing single record. See, from the GCP, all the data is lost. But because they had a backup in multi-cloud environments and hybrid cloud environments, like they have a data center, Azure as well as GCP, within a week, they were able to run their entire company as if it was normal. So this is nothing to do with technology. It's a human error. But strategizing, designing high available strategies is very important. Many of us, those who are working in senior management, they always tell that multi-cloud is very expensive. But it comes with a cost, but it can handle this kind of scenarios. Many people think that, oh, how come a cloud provider will delete? And how we all know that someone who understands the internals of cloud, they always tell that, oh, if you are storing something in S3 bucket, it's always replicated in 2 locations, 3 locations. But look at Google, they also replicated the data in 3-4 locations, but they have deleted the subscription. When the subscription is deleted, every copy that is located is deleted. We need to understand, right? When the subscription itself is deleted, doesn't matter if you have 20 copies or 30 copies, all of them gets deleted because all of them are linked to your subscription. That's something which is very important to take care. And that's why we ask you to have this multi-cloud strategy and have solutions which can handle your data at multi-cloud, and adopting frameworks like CIS, NIST, cloud maturity metrics will help you to assess this kind of strategy issues. There's another one common threat is insecure software development. And let's look at an example here. So Equifax, which is a company, has started using an open source software. But the problem is, it's not in the, people adopt open source software, and some of the open source softwares are very good, but it depends upon how you are using that software. Did you do due diligence before consuming a software? Today, many of the software developers, what they do is, they just go ahead and, in case if you are a Java developer, you just go ahead and take a library and add it into your POM. If you are a Node.js developer, you just do npm install and then start using the library. If you are a Python developer, you just do pip install and then start working on it. We never validate those libraries are good or bad, how good these libraries are, what kind of bugs or vulnerabilities that are there. And infusing these third-party components into our resources or components can actually cause issues. One more example here is to understand about Microsoft. Because many people use SolarWinds, SolarWinds was using some of the open source softwares. All the customers of SolarWinds like Microsoft FireEye also got affected. And then there was iPhone security issues for zero-click exploits because of the supply chain. because I'm going to purchase a software from one person, and that person could have used open source softwares to build his application, will definitely impact me as an organization. Yeah, this kind of unsecured third party resources or libraries and insecure software development practices can also cause cloud issues, and we need to put controls against all of them. Sometimes, if you take infrastructure as a service, right, a lot of systems are under your control. The operating system is under your control, the database application configuration management is under your control. Improper management of these operating systems, improper management of these databases, access control, zero day exploits can cause system vulnerabilities. And we see that many people think that, oh, I have an operating system which is sitting on the cloud. I take an infrastructure as a service. Let me take that as an example. So many people think that, oh, I chose infrastructure as a service. Now I go ahead and spin an operating system. People think that this operating system patching is cloud responsibility. No, because the operating system is in your control, cloud provider will never patch it. Cloud provider may provide you automated patching options, but they will never patch it for you until and unless you enable it. That you want auto upgrade to happen, auto upgrade of the kernel, auto upgrade of a patch, and what is the patch cycle that has to be maintained if you are on Azure can be taken care. But many of them doesn't come as a predefined configuration that has to be explicitly enabled by the system administrator or the cloud administrator. So even system vulnerabilities in the world of cloud are pretty much possible. And the other threat is an accidental disclosure. And let's look at one important. Again, it comes from the SolarWinds, because SolarWinds has it's a big attack which happened in a couple of years back. The other one is a misconfiguration, and this is nothing to do with small companies. Big companies like Tesla, was a victim of this kind of an attack. So because we all talk about these latest technologies, serverless models, going into PaaS and cloud native infrastructure, it's important for us to even put security measures on container workloads or serverless workloads, managing the code, managing the APIs and the keys that are securing these data that is encrypted. So these are some of these threats that we were discussing. Before I jump into a different part of how do you secure. So till now we were discussing on the threats. Now we will take a minute of pause. Let me quickly have some water and then continue discussing on our mitigation techniques. So how do you mitigate all of these threats which are common? Give me quickly 30 seconds of time and then we can resume. So how do you start with mitigation techniques? So typically, if you are a senior management, let me start with some strategies. These are the top 6 strategies that any organization is in case they want to implement defensive measures against this kind of threats, is to start with multi-cloud environments. Rather than having single cloud, let's go ahead and distribute our data or applications across multi-cloud. Again, I'm not. I know that there is a lot of cost involved in multi-cloud infrastructure, but you need to balance out. You as an organization has to take a decision between whether you are worried about cost or whether you are worried about availability. There are some applications where 1 second downtime will cause a big chaos. And there are some applications where you just let the server be shut down for 1 month. No one will care about it. So it depends upon how sensitive your application and how many customers are dependent on your application. For example, tomorrow zero the stops. Everyone will cry. Tomorrow NSE stops. Everyone will cry because a lot of people have invested, and then you cannot go ahead and take a 1 minute, 2 minute, or a 30-second downtime over there on a working day. but maybe a food app is closed for 1 year. Maybe the only the service provider will cry, but I have other food apps, or I have restaurant which is still running. I can go ahead and run the show. So based upon your sensitivity of the application and how much availability you want, you can take a decision here. So adopting hybrid and multi-cloud environments is one strategy that you can build in. And today, most of the issues happen due to misconfiguration, insider threats, improper configuration management. Adopting something like zero trust architecture. Now, zero trust architecture at an application level, zero trust architecture at a network level, zero trust architecture at an data management level. All the three has to be implemented so that you can protect against data application as well as infrastructure issues. And today everyone talks about fancy terms called artificial intelligence and machine learning. Again, it's important. For example, there are some components like Azure Sentinel. If you have seen Microsoft Copilot with Azure Sentinel integration, where your incident response, incident management, and incident automation has been the pivotal picture. So if you guys get chance, go back and look at a Microsoft webinar, which is on Copilot in Azure Sentinel. Azure Sentinel is a SOAR, where they have implemented AI/ML to do incident response and management SOC activities using Copilot. Today we look at Splunk. They come with AI/ML models. You take any of these SIM SOC management tools, comes with AI/ML tools. The same SOC tools which are available on the cloud has AI/ML implementation, because it will actually decrease the time and improve your response times. The amount of time that you take to manage an incident will decrease, and you can do the same thing in a faster way, a lot more automated. The other area that everyone is actually looking at is DevSecOps. So because if you are switching to PaaS model, yeah, application is the core. Data comes after the application is built. And if you are focusing on the application part, it's very important for an organization to do something called as DevSecOps. In a DevSecOps, also called as left shift of security, in a left shift of security, what you do is, from the day one, when you're capturing the business requirements for your software application or the system that you're developing, you will start taking care of security. Like at the design phase, you will do an activity called as threat modeling. At a coding phase, you will go ahead and ensure that all the components that you use, like software component analysis, third-party library management, secret management is taken care. At the time of build, at the time of managing the builds, at the time of signing the builds, deploying the builds in different stages of dev, QA and prod, everywhere, at every stage of your software development lifecycle, whether you take an agile model or a waterfall model, security has been embedded into it. And this is one of the common practices when you go onto the cloud. And then security automation. I'm sure you all understand the importance of automation here. The only edge that clouds can give you is automation capabilities. Almost every cloud provider comes with SDKs and CLI softwares, so that we can do a lot of automation from the time you provision the infrastructure, or on a continuous maintenance of the infrastructure, or converting the entire infrastructure into a code so that you can reproduce the infrastructure on a different cloud provider. Automation plays a very important role. And adopting cloud, open source cloud solutions. When I say open source, being a cloud native guy, so that tomorrow AWS says that, hey, I'm going to increase the Lambda cost. Lambda is a serverless model where you just go ahead and put your code and it will run. Tomorrow, let's say AWS increases the Lambda prices double. Right now they are charging, let's say, $5 per minute. And they say, no, from now we will make it $20. You're stuck with them. Tomorrow you cannot go ahead and take Lambda code and put it on Azure. Or you cannot go ahead and take that code and put it on on-prem devices. So it's important for you to adopt to cloud native open source solutions like Kubernetes, where whether it doesn't matter whether you're on-prem, whether you're on Azure, whether you're on GCP, you have a flexibility when you containerize your application to move from one cloud provider to another cloud provider, because Kubernetes is going to be same across the cloud, and you just need to migrate your existing pod containers applications from one cluster to another cluster. And that is actually seamless. If it is properly implemented, migrating from one cloud to another cloud provider is seamless. But there is a lot of thought process that has to go when you're building the infrastructure in the initial stages, so that your migration is very easy. And these are some strategies. But if you look at the tools and technologies that are available, let me put up on a timeline here. So in 2010s, virtual machines were very common, and people started using infrastructure as a services. We used to have technologies like cloud workload protection platforms. We call it as CWPP. This was there in 2010s. We are not talking now. This was there in 2010s itself on how do you protect your virtual machines which are running on cloud. And then people started around 2014 to 18, people started adopting containers, also called as platform as a service, where the containerization is easy, deployment of the applications, multiple versions of the applications can be maintained, all the containerization of the application configuration is taken care. So we have technologies like technology tools like cloud security posture management tools. And then we moved out from there, and people started adopting serverless models around 2020. Then the tool names have changed from cloud infrastructure entitled management. And then now if you look at, many organizations are adopting cloud native application development, which I was telling you as one of the strategies. Yeah, when you are moving to multi-cloud and hybrid cloud environments, the solutions that can protect this kind of environments also has to upgrade. And now we see tools like cloud native application protection platforms, which can help you to protect against multiple threats. Almost all of these products, to certain extent, I cannot say 100%, but to much of the extent, they can help you to protect against these attacks or breaches. So we always recommend you to have that strategies, tools that are up to date. So many organizations, in case if you have not adopted this environment, these tools may not make sense. But in case if you have adopted it, it is very important for you to do research on these technologies and then go with it. If I have to give you a very simple example, 10 years before, we used to call penetration testing teams. Now we call them as red teams. Even though red teams do offensive work, but we have given a fancy name to it, and we have added more roles and responsibilities. Very similarly, even though we are using infrastructure as service, even though you think this has a fancy name, but there are certain examples that I want to take here to really understand the kind of work that they do. If I take CWPP as an example, typically CWPP tools will take care of software vulnerabilities, malware issues, OS and software updates, patches, managing the misplaced keys or sensitive data. But if you look at CSPM examples, managing the storage bucket permissions, managing the network access control list, security group permissions, monitoring the identity and access management, and enabling you to implement MFA, or managing the CloudTrail logs, user management logs, can be some examples of how CWPP and CSPM are little different tools. Now, some of these CWPP and CSPM tools are there in the clouds, but you can take a third party also and implement it. Something like cloud infrastructure entitled management tools, like resource entitlement tools, where if an EC2 instance has more permissions, it can detect it. If an RDS, relational database service, can access an elastic file system or not, if an AI model can retrieve certain object from certain database, okay, if a Lambda function has the right permissions to write the log into a CloudWatch, maybe can I use S3 to distribute the data objects using CloudFront, or whether my identity and access management can manage my API gateway, or whether my billing management role has an entitlement to do billing alerts. So this kind of access management are handled by cloud infrastructure and entitled management. So there are different set of tools which are handling different parts. And if you look at the overall global structure, These CNAPP tools, which are little more advanced and provides you capabilities of CWPP, which were the old model. And then now, because we are moving on to PaaS and SaaS, where identity and access management and the data management plays an important role, CIEM and CSPM tools are going to play. So in case if you want to combine all the features, typical advanced CNAPP technologies would help you to protect your application, which is sitting on the cloud, as well as the cloud configuration itself. So these CNAPP tools can actually address across multi-cloud, whether you can choose any platform, whether you're on AWS, Microsoft, Google Cloud, or Kubernetes. Okay, whether you are running VMs, containers, or serverless models, or whether the data is stored in a S3 bucket, or whether you are using identity and access management, maybe a centralized identity and access management, or distributed identity and access management have SAML-based integration, or from a vulnerabilities point of view, malware management point of view, identity and access management issues, lateral movement issues once one of the systems gets compromised and a hacker want to move from one machine to another machine, or log management. Like any kind of a different attacks, today's CNAPP solutions are actually trying to help you to protect against these common threats that we were discussing in the start of the webinar. And one thing that I would recommend you here is the automation. Automate everything that is possible, from building your infrastructure, doing application configuration management, application upgrade, downgrade, integration of the application with third-party tools, continuously monitoring, and handling the incidents and remediating the incidents. That everything in cloud infrastructure process or application development process have to be automated. The more automation you do, the better it is for us to maintain the cloud infrastructure. And that's why now you see that everywhere Terraform is implemented more. Terraform, Pulumi, CloudFormation, whatever you take, Ansible, Puppet, Chef, this kind of configuration management tools are predominantly preferred because automation can help you to take actions in a fast way. So with that, I would like to pause this webinar here and leave some time for questions. And if you got any questions, we can go ahead and discuss them. And if you got any questions, in case if you want to personally reach out to me, feel free to reach out. And let me see if we have any questions.
We have a few questions, but we would want everyone to post your queries. I think first question we'll take from Dheeraj. How domestic cloud is different from hyperscaler, Nishant? That's the question.
Okay. Again, in a hyperscaler cloud, what typically happens is the kind of infrastructure that is provided. For example, if you want a GPUs, high amount of GPUs that you want as a single grid, you will get it on a hyperscaler clouds. But that is not happening on a current domestic clouds. If you have heard, Nvidia's stocks have gone up after the Blackwell release of the hardware. Now, if you are using Blackwell kind of a chips, you can call it as a hyperscaler cloud because they are most advanced chips, and the integration of these chips as a cluster or a grid is typically possible on a hyperscaler. That means you can think that they are a lot more advanced data centers than a regular data center. Today, CPU and RAM can be clustered very easily on a domestic cloud. But can I go ahead and cluster them as a grid on a domestic cloud? No. There is a fancy name for it called as hyperscaler clouds, where these kind of a GPUs integration is pretty much possible. It's the hardware that is supporting it. I hope that answered the question. In case if you have more things, we can post the corresponding question to it.
Okay. Somebody has asked about cloud pen testing resources, if there is any. We can maybe curate those resources and share if possible. Or is there a single place where we can get the resources?
I don't think it's like a single place, but for example, in case if you want to go to Hack the Box, Pond Labs, they are actually good to start with cloud pen testing. But be very cautious in what type of model you're using. See, if software as a service is the type of consumption that you're using, you don't need to do pen testing. That is cloud provider's responsibility. But in case if you're going for infrastructure as service, okay, which I want to just bring it up here. In case if you're going for infrastructure as service, there is nothing like cloud pen testing. What is cloud? Still operating system. A regular pen testing would work. Databases, a regular pen testing would work. Application, a regular pen testing would work. Data, a regular pen testing would work. You don't need to call this as a cloud because regular operating system. See, in today's case also, when you're doing a pen testing, you're sitting in some location, maybe in your 5th floor of your office. Data center is sitting in 7th floor or 8th floor or a ground floor. Still you're remotely connecting it. It is the same. Rather than sitting on my premises, the system or the operating system is sitting in maybe 100 kilometers far or 200 kilometers far or 1000 miles far. That's it. So when you come to infrastructure as service, regular pen testing is same. You don't need to get confused. Where the pen testing will change is when you're on a platform as a service, because the scope will decrease. And if you look at the major amount of the work is handled by the cloud provider. So pen testers will actually have lesser work from a client point of view. But if you are a pen tester who is sitting on the cloud provider's office, like, I'm a pen tester sitting in AWS, I may have a lot of work. But if I'm a client who is consuming OneDrive, I may not need any pen testing, or I may just barely need access review.
Okay, I think that's a very clear answer, Nishant. I think resources and all that, I think please spend some time to understand based on maybe pass along around that. Maybe you can go and check the resources. Vishal has some worry that he says the session has not been focused on cloud security tools and prevention. But towards the end, I think he got his answer. But say CNAPP, is that the solution that you are suggesting everyone, Nishant?
See, no tool is foolproof. No technology is foolproof. You can only delay the attack. That's it. For example, maybe without implementing a firewall, I may get attacked in one day. By implementing a firewall, maybe it will take 2-3 days extra for the hacker to hack me. So I cannot say that you implement tomorrow CNAPP and it will protect your systems. You implement CNAPP and use weak authentication or improper misconfiguration, your CNAPP will fail. It's very similar, right? You go ahead and build Pentagon. The architect of the Pentagon reveals the blueprint outside. There is no point. You build a secure premises and the architect exactly knows the weaknesses. He puts it out. There is no point of building in a Pentagon kind of a scenario. So what I mean to say here is that implementing solutions properly will only delay the attack, but it cannot 100% close. I think no one in the world can claim that I'm 100% secure. But the moment I think people claim there are a set of hacktivists or people, hackers with ego mindset, they will definitely attack them and show that how good they are.
Yes, absolutely. There's a question which is a career question from Mohammad Aswad. He says he has 15 years of virtualization experience and with an IT giant. So is it a wise move for him to move to cloud security?
Okay. So one thing, let me tell you guys, doesn't matter what domain you come from. If you ignore cloud, then it's a problem. Let's say you're a system admin. Still, we need cloud administrators. Okay. Let's say you're an automation engineer. You still need to do cloud automation. Let's say you're a pen tester. Not every client may take you as a pen tester, but there are cloud provider companies who will take you as a pen tester. Okay. If you are a developer, now every cloud provides you a lot of services. That services have to be integrated into your application. That is only possible with the help of a coding. If you want to integrate a queuing service, even though queuing service is provided by AWS, if you have to integrate that queuing service into your Java application, you just need that library knowledge. That itself is that means any developer can move. Whether you are coming from DevOps background, whether you are coming from automation background, system administration background, security background, because ultimately systems on the cloud has to be secured. Maybe the way you do the configurations will change, but you cannot ignore cloud. Oh, I'm a machine learning guy. Why do I need to learn a cloud? Where will you get GPUs from? In next 5 minutes, you want a terabyte, megahertz GPU, or maybe you want 40 teraflops of CPU or a GPU, whatever it is. You cannot get just like that on a on-prem solution. You have to go to the cloud, and obviously today's cloud solutions are more advanced, and model evaluation is typically done automatically. There are so many ML tools which can actually increase the model development process. So it doesn't matter what background you come from, you have to learn cloud, because cloud has around 2 plus. If you take only AWS, there are 250 plus services. So for every one of you who is coming from a different background, there is one or other cloud service that you have to learn.
Absolutely. We also would discuss about our cloud program after this, Nishant. There is one more question that adopting to multi-cloud, is that a good solution? Is the question.
I think after this example, I feel it is important. I've seen the UniSuper example, right? Who expected that Google's engineers will delete all my subscription? Do you expect? Did they expect it? UniSuper. We never expected, and it happened. And we have to always learn from previous incidents. See, there are two ways a company learns. And in cybersecurity, this is what we do. Either you face the attack or you learn from someone's attack. Someone has faced it attack, as a preventive measure, you implement it. Or you wait till the attack happens on you and then implement it. I think that's a wise solution that you as an individual has to take. I'm sure no company want to get hit with an attack and then take a solution. Rather, you will do preventive measures. Okay. So as a preventive measure, it is better to use it, but you want to wait. Again, as I said, it comes with cost. See, if you want 99.99 availability, it comes with a cost. If you want 99% availability, it comes with certain cost.
Yes, absolutely. Yeah, so there is one different question. I am a security auditor. How to improve my skills on cloud security as an auditor? Are there any courses or certifications? We will discuss about the courses, but how to become a security auditor is the question.
Again, because I have done multiple audits in my career, more than 35 plus external audits for different companies and implemented, I can very easily vouch that many auditors have a mindset. Again, I'm not telling latest these generation auditors, but there are auditors with 50 years of experience, 20 years of experience. They always think that GRC audits, if I do, I'm fine. That means, oh, policies are there, procedures are there. If I go ahead and audit, if the roles and responsibilities are predefined from a governance point of view, if I do governance, risk and compliance audit, I think my auditing is done on cloud. This is what many auditors feel. These are non-technical auditors. If you want to be an auditor in cloud, GRC will not help. You should go into configurations, because see, today every organization have a policy. I want to secure my organization. There is nothing much in it. Okay, every organization, any consultant you hire, right? He will just give you the set of templates. You just rename your things. Again, being a consultant, I have done this multiple times. We have templates. Many organizations want to implement their cloud security policies and strategies, risk management in 2-3 weeks or 2-3 months. We complete it. Okay, and they are also happy. We are also happy. We get paid. But what is not taken care is, an auditor will never go to IAM configuration, look at the IAM configuration and tell, see, you have done a misprivilege. Many auditors, you know what they do? They ask you to open the RACI matrix, which is in Word document, PowerPoint or Excel. They look at it and they will ask, do you have emails for this? Do you have emails for that? Oh, do you implement it? Just show me one configuration. But how many auditors will run a quick Terraform script, Ansible script with CIS benchmarks and compare it? This is the gap that is there. If you are an internal auditor, or if you are an auditor, this gap has to be filled. And if you fill this gap, I think there is a lot of value to that auditor.
Okay, there are questions coming on our program that we will take it later. There are very specific questions. Say digital forensic, how do you do on multi-cloud, and how to handle SSO on a multi-cloud environment?
Okay, so in case of an SSO cloud, what happens? Let me quickly put that in the form of a uh, diagram. Just give me 1 minute. In a typical SSO, what would happen in a typical multi-cloud environment? What would happen is, doesn't matter which cloud provider you are. Okay, let's say this is GCP, this is Azure, this is, let's say this is GCP, this is Azure, and this is on-prem Kubernetes cluster. Okay, again, whether it is an on-prem Kubernetes cluster or Azure or GCP, what is common across them is Kubernetes cluster, Kubernetes cluster, and a Kubernetes cluster. Let's say this is on-prem. On top of that, you run typically called as pods or deployments. I'm just taking it as a pod. Pod is a representation of a Kubernetes environment. Good thing is, once you configure your pod, you can move this pod from one Kubernetes cluster to another Kubernetes cluster just like that. And you can move from here to here just like that. That means in 1 second, if you want, if the Kubernetes cluster is properly configured, you can just move your Kubernetes from one location to another location within seconds. Assuming that the Kubernetes cluster is properly configured across. And in cloud, digital forensics is a little tougher job because resources has come and then resource gets deleted in seconds. Let's say if I have done auto-scaling group where I have a lot of peak traffic coming, maybe 10 systems will come up at the same time, and in the next 15 minutes, the traffic has gone down. Out of 10 servers, 9 servers are deleted because the load has gone. Maintaining the trace in case of a multi-cloud environments and cloud environments is a little tougher job. That's why cloud forensics is not a grown domain at this moment, because the challenges is the cloud can scale at any speed. You ask it to create 100 servers. If you are ready to pay, it will scale to 100 servers within that given time frame. It can be 5 minutes, 10 minutes, 15 minutes, but it can scale. And at the same speed, it can come down. So you don't have so much of comfort to go to take a memory. Like if you want to do memory forensics, you don't have so much time to go pick up the memory from there. By the time you go, maybe that server could have been turned off. So that area is something nascent. I think many people don't even need it if they really go with it. But if you are an organization who is implementing infrastructure as a service, maybe cloud forensics is an area that you will look at. But someone who is taking platform as a service and SaaS, you may not even need that kind of a service, because most of them are taken care by the cloud provider. As long as you are maintaining, you are monitoring that services, you should be good enough. I think that has answered both the questions. Let me see if that did not answer.
Yes. So we can see that there are a lot of questions, Nishant. So I'm not sure how much we can take, but we will ask some persistent questions. We'll take it.
Yeah.
So are there any frameworks? This is Kiran's question, that we can use across AWS, GCP, Azure. Is there a way that we can implement same framework across?
Yes, we have a cloud security matrix from CSA. Let me just give it. Okay. So we call this as cloud control matrix. Okay. You can just download this cloud control matrix from the internet, which really talks about different kinds of security controls that you can put irrespective of the cloud provider. So that means they are very generic, but you have to understand there is one gotcha or catch, whatever you see here. Let me prove that with a simple demo thing here. See, when you take a cloud, there are generic names and there are specific names. Let me give that and come back here. Look at this, right? See here, even though it comes under compute category, in AWS, you call it as AWS Amplify. In Azure, you call it as Web Apps. In Google Cloud, you call it as Firebase. You guys can see me and hear me, right?
Yes, yes.
Okay, perfect. You can, in IBM, it's called as web hosting. Now, when you take a generic control, it only tells you that apply secure coding practices. But how will you apply secure coding practices in Amplify, Web Apps, Firebase will be a little different. Look at it. You need to have that mapping because there will be a lot of difference in the names. Let me take one more example. You see here, serverless compute. If you look at AWS calls them as Fargate, Azure calls them as container instances, Google calls them as Cloud Run. Now, these cloud control matrix that I was talking about will never talk about whether you have to do amplify configuration, whether you have to configure Fargate, whether you have to configure, because these are generic controls. Now, generic controls will be an inspiration for you to make a specific control. You cannot take generic controls and apply because they will say secure coding practices. Now, irrespective of where you use your code across all these services, you need to follow secure coding. So, from my point of view, generic controls will help you to build specific controls. So there is a lot of work that as an individual you have to do. In case if you are taking generic metrics and then based upon the services that you consume, you convert that into specific configurations. And one more resource that I would recommend highly is CIS benchmarks. They are very good. CIS benchmarks has very specific, let me go there, I'm sorry. Oh, always this comes from me. Okay, so I would highly recommend people to go to this and look at the configuration which is very specific to the cloud provider. Again, if you want a vast list generic multi-cloud, I think this would be the best resource that I found and I use it on a daily basis. And the other one is the CIS benchmarks. That would really add value to you. In case if you are coming from a specific cloud provider configuration like Alibaba specific configuration, Amazon specific configuration, Google Cloud and all. One good thing is, again, just to tell you, at Reva University, we teach this, that, even though you are a multi-cloud, how do you do it? And we do automation for multi-cloud.
Absolutely. I think, Kiran, I think you may have to go and check this resource because further questions are coming. Is the framework covering cloud storage problems like confidentiality and authentication with decentralization? Is that covered is the question. But I think let him go and read is the suggestion.
Any other interesting questions?
Okay. I think there is one question that there is a need to clarify. I'm just taking there. This is Dheeraj. He says multi-cloud connectivity, not multi-cloud alone. Can multi-cloud connectivity as a software defined can save all the egress charges? Means any changes in the egress, can this multi-cloud connectivity, which is a software-defined cloud interconnect, can it solve?
Again, it depends upon the type of cloud you use. If you are using a firmware, which is a part of the cloud, for example, some cloud providers, what they do is they give this multi-cloud integration. Okay. See, I'll tell you very simple. Nothing is for free. Cloud providers will never give you anything for free. That too, egress is not at all free. See, the strategy that cloud providers implement is incoming is free, outgoing is charged. And I think you have seen this in telecom providers also, that outgoing is always charged, incoming is always free. That means if you want to upload millions of terabytes of data, they will say you, okay, go ahead and upload, no problem. But the moment you start downloading them, some or other cost they will charge you. I cannot say it will be a zero cost. Based upon the cloud technology implementation, that will change. But you have to pay some cost. The cost of multi-cloud integration, sometimes it will decrease, but it depends on very specific implementation, like for example, VPC to VPC connectivity or VPC to VNet connectivity from a third-party provider would actually change the cost. If you have a direct connect via a third party, it's different. So I think it depends upon the architecture, but the cost will change, because at this moment I don't understand full infrastructure of the setup that you are talking. So I may not be in the right position to comment on whether it will decrease or increase. It all depends on the implementation. But there will be a change in the cost, and cost variation will come.
Yes, and we will take the last question, which is, Can you share a career roadmap if somebody has to move from a fresher to an expert? What is the career roadmap available in cloud security?
Okay, See, there is no one shoe that fit for everyone. Let me tell you this background. Let me take with a very simple example. Let's say you're a finance and accounting person. A very simple example I'll take. Let's say you are a finance and accounting person. Can I make a career in cloud? Simple question. Yes, you can make a career in cloud by using a concept called as FinOps. If you are a finance professional and accounting professional, and if you want to make a career in cloud, you have to become a FinOps professional, where you as a finance person manage the operation cost. And his learning path would be entirely different from a person who is coming from a software development background. Let's say I'm a CI, computer science, IT background. And if you have to really so sorry, that was a cut. So just to tell you out, that based upon what is your background, the cloud path will change. For example, let's say you are a person who has completed your master's or bachelor's from data science background. And can I go ahead and make a journey in the cloud? Your path will be a little more different, because if I just take AWS as an example, if you look at the solutions that are available, each area different solution. Let's say you are an electrical background, IoT background. If you are a person who is coming from mechanical engineering background, maybe services like IoT core, IoT devices will help you. Maybe if you are coming from a cybersecurity as a specialization, as a fresher, and you want to make a career with cloud and cloud security, your path will be different. I would highly recommend you. What we do is, once you are done with this webinar, we may actually share you some form, Google form, where you can actually put up your questions. And if you are interested, we can have a one-on-one session after this. Okay, where we will actually give you one more session of career counseling and mentoring, where we take direct questions from you, where we can really give you a tailored solution. I don't want to sound very generic here, because it all depends upon the background that you come from. So that's why rather than putting up a generic plan, having a specific plan will help you.
Absolutely.
And it will be obviously more crisper.
Yes. Yes, I know there are more questions on the same lines which has come because of the paucity of the time. Nishant, can we move to introduce our program?
Sure, doctor. Yeah. You can see my screen, right?
Yes, yes. Yeah.
Okay.
So Nishant has given a very, very wider perspective on multi-cloud, the security threats especially, and a few solutions. What you have seen is maybe a glimpse of what we do here. Under Reva University, which is one of the largest private university and a highly renowned and top-ranked university, we have been running various courses. We have about 15,000 students. We are located in Bangalore. Beautiful scenic architecture, the kind of programs that which we run. Next slide, or I'll just share my screen. Nishant, you would want to just move to the next slide.
Yeah.
Okay. So we have a division called Reva Academy for Corporate Excellence, where we focus on building careers in these emerging technologies. So we are in AI, business analytics, cybersecurity, cloud technologies. And how do we run these programs? We not only do certain long-term master's programs, but very customized niche programs as well for working professionals and organizations. And that is because we have this ecosystem of, say, 1,000+ learners who comes from various marquee organizations. We have 50+ industry mentors, and Nishant is one of our expert mentor in cloud and cybersecurity programs. And we have custom-made 300+ courses around these technologies. And ours is more of an interdisciplinary techno-functional programs that which we would create. And Nishant, if you could move. So we want to also share that the whole ecosystem consists of a lot of people, aspirants who wants to move to these technologies. So we not only be part of the training, but also we are in the career transition progress also for these people. And next, if you could move to the program itself on the cloud. Yes. So we have a program. One of the program which we do is called Cloud Architecture and Security. We could be on the program page on the Nishant on the program, the how the whole program is being designed. This is a master's program. It's a 2 years program open to all the working professionals who have some relatively good experience or some experience in IT and wants to move to various cloud. So we use AWS and Azure as our major platforms, and starting from the basics of network, setting up networks in cloud to running multi-cloud applications. Everything, the depth and breadth of it, using at least 2 or 3 clouds is being hands-on being taught here. And you can see the kind of programs. So though this is not theoretically driven, these are very well laid out with labs and practicals. What you would also get is a series of programs around certifications. So what Nishant is mentioning is that along with the master's degree, you will also get 6+ certifications. So if you see the Azure track, starting from fundamentals of cloud, AZ 900, moving to administrator 104, and then infrastructure design 304 5, plus security, which is AZ 500, is covered under Azure. So you can get an excellent understanding on setting up, administrating, operating, and design of the cloud. Similarly, the AWS track, if you see, certified SysOps and then architecting, that means the administration as well as design part of it has been. The rest of the modules we put together a very robust plan connecting these 2 clouds, and how do you actually create that containerization orchestration. How do you run? The Nishant discussed about what are the pitfalls in IDAM experts even today. So we have dedicated program on it with multiple clouds that we will configure various IDAM policies and then move on to various governance risk compliances policies. How do you configure it across these 2 major cloud platforms? And also the last part of it, which is very interesting, is that how do you deploy products and then monitor the applications with security as well as privacy in mind. And end of it, we will also help you to run a project, an end-to-end project on the cloud. There are a lot of automation projects which Nishant has mentioned that we run here, and that means that becomes your gateway to enter into the cloud. So we will have dedicated mentorship. We would have a series of activities around how do you actually create automation or any projects which is very solving the real industry problem in cloud security or cloud architecting itself, and then convert that project into a publication. So your whole resume changes, your whole understanding changes, the number of opportunities which you can apply if it is Azure cloud or AWS cloud or multi-cloud applications or an end-to-end the net setting up to deployment, anything which comes in between, you would be able to apply to these jobs and would want to move. And those who are already in the cloud, they also join this program, because we would one is that there are a lot of certifications inbuilt. It includes, our program includes all the certification training, vouchers, plus we are also a Pearson View Center here, so you can write the exam and then complete this. So 6+ certifications plus almost 16+ modules, 2 projects which are mentored with 1 publication. We have seen is almost 250% hike. Our average hike for our participants is about 250% hike, and anything as a lowest is about 70%, up to almost 500% career transitions we have seen in terms of salary hike. So we would request you to go through. There are a couple of no the links have been shared with you. Please go through, and our team are here to help you. There are certain numbers that which we have put on the screen. Next screen, I think there are numbers. Yeah. Yes, the numbers are missing. Okay, so we will, yeah, so this is the website. You will get a lot of career transition use cases across programs, right? So please do connect with us, and with that, let us take a minute to thank Nishant. Nishant, I know it's a 1 hour program. We are trying to understand the depth of various clouds, but at least we are hoping that you understood to some extent how insecure the cloud could be, all because of the people who are configuring clouds and deploying products and applications. And you could be the person that who are fixing all these cloud problems for organizations, right? And I hope Nishant has given you enough insights into this world which is available to you to explore, and also some glimpse of how to mitigate. But there is a lot of learning involved. You would have seen AWS website that it is just opened up, that so many sectors, so many applications, so many domains that you need to apply. It requires deep learning and dedicated, focused, mentored, structured program. And that's what we are very, very glad that we would be able to help you in that journey towards moving and becoming a cloud expert to all of you. So Nishant, it's been always a pleasure. Any last thoughts, Nishant, you want to share?
Just to tell you, everyone, that if you are a Java developer working for 10 years, can you 100% tell me that I know everything in Java? You know barely 20% of Java, but still you are working for 10-15 years as an architect. Very similarly, don't expect that if you work in 3 years in a cloud and you will become pro in cloud. By the time you complete the services, there will be 200 plus services that will come. We have seen that, right? In the last 6 months, I have seen 4 different AWS services which have come, which has been outdated also. Very similarly on something like Bedrock, okay? And chatbots. They came, they got outdated, and new versions released. So don't expect that you will become expert in everything within few minutes or few years. It's a continuous learning journey, and this area you have to start. If you don't start right now, we will be left behind. So with that,
Absolutely.
I want to thank.
Thanks, Nishant. Very, very important. Nishant has been an expert, but if you see his learning curve, it's always has been up. He moved from maybe one cloud. Now he is on to DevSecOps, FinOps, cloud deployment problems, privacy. I think there are various areas, very fascinating areas that he is doing projects for various organizations, and that actually shows up in all the presentations. Nishant, thank you so much, and thanks everyone for joining and spending the time with us. Hope this has been very useful for you. There is a forms which has been put up by Nikesh from our team. Please go fill up the form, and we would connect with you back. And please keep tune in for our webinars. And if you find it useful, please share it in your social media channels as well. Okay. Thank you so much, and good night, everyone, or good afternoon, wherever you are from. Thank you.
Good day to you.
Good day.